Hello everyone, my name is Victor de Oliveira. I am a data science intern at IBM Research Brazil. I am pleased to say that I am concluding my certification on the Coursera course IBM Advanced Data Science. And this is a presentation about my Capstone project where I explored the world of sentiment analysis classification using Twitter data. Hope you enjoy. This will be split on three parts. The first one I will do my stakeholder presentation, then I will do a little demo of my product developed, and then I will start my technical presentation. So let's begin with my stakeholder presentation. Here, firstly, as I said, I will do my stakeholder presentation where I discuss motivation for my work, applications in real environments, and the data product developed. Motivation. It's well established that companies who interact with customers in social media have better understanding of their quality services. Since we have an increased number of users on these platforms, it becomes necessary to analyze data coming from Twitter or other social medias to check companies' levels of satisfaction based on comments sentiment. Taking into consideration the problem stated, we developed a product based on a data-driven approach where we used machine learning to classify data in a fast and response manner, checking if a new tweet is either positive, negative, or neutral. This way, we can focus on services that are not doing so well and improve internal processes. The dataset chosen comes from Kaggle. It is a Twitter collect dataset based on sentiments from US airline companies. They were all collected in February 2015. This is an excellent dataset to work as a real case scenario because we can label automatically customers' perspective on the company's services. Based on this dataset, we developed a product, a deep learn called long short-term network, as well as LSTM. Basically, it is a model whose architecture works better for sequential data, and as we know, text is a sequential data. The model was developed using PyTorch library, excellent for deep learning algorithms. We also worked with a REST API where we could just send a new tweet and we would, as a return, get its probabilities of being one of the three classes. Now we'll do a little demo about what I have achieved. Here I import the data. I do the test and train speed again because I want to show my results on the test set, not on the train set, because this would be overfitting. Here I collect 5 tweets, so these are the tweets we are going to classify, to predict probabilities, sorry. I will do my model imports here, and its hyperparameters. Here I am loading the best model achieved. I will discuss the details on my technical presentation. And here I am analyzing tweets probabilities. As we can see, that this one is classified as true label. Our probability of being negative is 93%. Here we have also a high probability of being negative. The true label is negative, as expected. Here the true label is positive. We have also a higher probability of being positive. Here we have also the same result. And here we have an interesting result. The true label is positive, but we get a probability of being negative, higher than positive, but not so higher as the other ones. And this is because, why? I don't know. Maybe we have the word thank you here and the model confused itself. But this is an excellent demonstration that our model is not perfect. Therefore, we would choose in a real scenario a threshold probabilities to count negative and positive tweets. Now I will start my technical presentation. I will talk about data exploration, feature engineering, model evaluation, and I will do my final comments. Firstly, let's talk more about my ADD overview. This is an overview of my architecture decision documents. I have choose to work with libraries related to batch processing and a single node CPU since I had a small dataset. Thus, I use pandas, matplotlib, seaborn for preprocessing data and visualization, respectively. For classical model developed, I used scikit-learn, and I also used natural language process toolkit for feature extraction based on negative words, polarity scores, part of speech tagging, and so on. Next, I did my initial data exploration. One of the first steps in any data science project is exploratory data analysis. Here, we did a series of graphs showing distributions to help get insights about our features and possible new ones. Also, we checked to see if our data was consistency, if it has null values, mistakes from input values, and so on. These two graphs are examples of some visualizations in my notebook, in my project. The upper right is about emoticon sentiment count, where we can see that on left, positive tweets have a huge amount of positive emoticons, and the same happening for negative. This is something that we would expect, of course, but it needs to be checked. Therefore, we could extract an extra feature based on emoticons counting on our tweets. Here I am showing the words relevance, two other graphs that I found interesting to show. Here on the left we have the most words appearing on positive tweets, and on the right negative tweets. Now I will talk more about the feature engineering process and ETL. Here we have two phases, data cleaning and feature extraction. For data cleaning, we had lowercase, removing links, hashtags, user stations, steaming, tokenization, label to indicate presence of emoticon and its sentiments. For feature extraction, we use polarity scores, presence of negation words, and bag of words based on count and term frequency inverse document frequency, the so-called TF-IDF. This, after all this pre-processing, this would be my input for my classical model. Also, I did feature engineering for word embeddings, where I use word embeddings based on my own text given from tweets, and the glove embeddings from Twitter data found on Kevin. This would be my deep learning model input. The model definition was based on a cross-validation with a varied set of features. As we can see, we have just a small example here. I tested the classical algorithm just such as support vector machines, naive Bayes, random forest, and I contrasted with deep learning models such as LSTM networks. Here we varied our features for example, for SVM, the C value, it's a penalizer for points getting longer on the wrong side of the hyperparameter. Hyperplane separates the values. For random forest, we varied the number of estimators, that is the number of trees, and the LSTM network, the embeddings from text as discussed, and embeddings using pre-trained glove Twitter text. The model evaluation metrics were based on accuracy, recall, precision, and F-score. They were important because we have an unbalanced data set, and just accuracy wouldn't be enough to evaluate our models. As we can see here, the two best models are SVM with migrants, 80% of accuracy, and LSTM with 200 glove, 82% of accuracy. And also for LSTM, we had an F-score higher than all of the other models. This is a good indicative that this is an excellent model for a real product. Also, I analyzed the confusion matrix. As we can see here, the best two models are on the middle column, where we have the LSTM networks and SVM migrants. Here, even though SVM migrants get more right on classes like negative, it's poor classification based on neutral classes. And in contrast, our LSTM network gets more right points, sorry about that, gets more right points in neutral classes and positive classes. And overall, they were the best model achieved. I hope you enjoy my presentation. Sorry for my English. If you have any comment, feedback, you can also check my notebooks on the link I will leave on my YouTube video presentation. I am excited to explore new tasks as I'm work with text classification in my university. And that's it. Thank you very much. Have a good day.